So, ladies and gentlemen, we are here and going to welcome to this fourth day of FDP on Advanced Research Methodology Analysis and Interpretation using SPSS and AMOS. And hope you are enjoying the insightful sessions last 3 days. It is my great pleasure to introduce Mr. Pankaj Chauhan to be a distinguished speaker for the fourth day of this FDP on the topic data modeling and practical cases with a dataset using AMOS. Professor Pankaj Chauhan is an educator who aspires to simplify the complicated things. He is associated with AKGIM Ghaziabad. He is a member at GMA, a body of All India Management Association. As a resource person, he conducts workshops in the area of STP modeling, analytics, and research softwares. He has published research papers in various index journals. Recently, in 2020, he has contributed more than 15 video lectures of strategic management for official YouTube channel of Dr. APJ Abdul Kalam Technical University, Lucknow. His research interests including strategic branding, design thinking, innovations in tourism, retail, and OTT industry as well. Mr. Chauhan's expertise and experience in the field of education make him an ideal candidate to share valuable insights with our esteemed participants. Through his innovative teaching methodologies and deep understanding of pedagogy, he has consistently empowered educators to deliver transformative learning experiences. Mr. Chauhan's session will undoubtedly be a highlight of our program as he imparts his knowledge and expertise on marketing, research, and analytics. We are honored to have Mr. Pankaj Chauhan join us for this FDP, and we are eagerly anticipate the valuable lessons he will share with us. Pankaj sir, the stage is all yours now.
Thank you, Professor Ritesh, for such a elaborative introduction. In fact, I just a faculty member over here. These are the things that everybody actually perform and manage to do. So let us start this session today. I was asked to deliver a session on the AMOS. I was listening to the various speakers who were invited, and when I was planning today's session, I decided to break it into certain sections so that we can easily move through one part to another part. I'm not directly jumping to the AMOS interface and how the model is built up and other things. I try to create a kind of connect that how the things actually work out in a model, and before moving to the SEM, structural equation modeling, and using the AMOS, what are the different things one should actually perform for the better results. So let me just share my screen. Is the screen visible?
Yes, sir, it is visible.
Okay. So as such, I do not have much of this slide kind of thing because a lot of things to be mentioned by writing on the board. So as I told you that we will be discussing the AMOS and its practical application into different sections. The first section that I'm going to start is that what is SEM, structural equation modeling, and why do we require this structural equation modeling? So just for the sake of and understanding about the SEM, if somebody can contribute. You may use the chat box if you want. And if you even want to discuss, you can open up your mic and then discuss. Okay. So let me do my job. When we talk about SEM, so SEM is a combination of regression analysis and factor analysis. The first thing is uh, SEM is a combination of regression plus factor analysis. So in the last session, we have already gone through the factor analysis, how factor analysis to be performed on the SPSS, what is the purpose of it, and how to give the interpretation of the output. If required, I will definitely be referring to the results of factor analysis because they might be a kind of reference that I will be using in the SEM. So when we think of the structural equation modeling, what does structure represent? Right? Equation we understand, modeling we understand. What is the structure here? So the structure is basically the structure that is represented by the regression equation. So this structure is basically the regression equation structure. As I was telling you that SEM is a combination of these two techniques. So SEM, but obviously does something more than the normal regression equation. Otherwise, why one should be using SEM? So for the first 5 minutes, I will be spending on the relationship between SEM and this regression. So SEM actually take into account the psychological constructs that are not exactly properly handled by the regression equation. So for example, if there is a data set saying advertising expenditure, and it has a connect to the sales. So in this case, we know that this advertising expenditure is real, right? Sales figures are also real. But if I say that incentives and motivation, now these incentives are real, but this motivation uh, to understand or to measure how much one is motivated by certain incentive, you need to discuss something or you need to ask the person how much is he motivated and what he is feeling about the incentive and other things. Then only you will be inferring the level of motivation. Means like advertising expenditure, you spend money, you have a count of it, and then you can see that how much sales has been increased. So herein you basically you have the values which actually reflect how much has been gained out of expenditure on advertising. But now if you're spending incentives, you are paying, for example, 1,000 rupee incentive to a particular salesperson. So after offering incentive of 1,000 rupees to the salesperson, how much motivation he gained out of it? It is not defined actually. So this sales is the dependent variable. This advertising expenditure is independent variable. If you change here, the change will reflect in the dependent variable. Similarly, incentive are also the independent variable. Motivation is dependent variable because if I offer certain incentive, definitely it will show the reflection in the motivation. So as such, if we go with the assumptions of the regression, it's a case where I can apply the regression. But the point is, these three aspects, advertising, sales, and incentive, these are the ratio data, the real data. Wherein if somebody say I have spent 100 rupee, it means 100 rupee. If somebody say I obtained zero sales after spending it, it means it doesn't work actually. But in case of motivation, how will you measure it? That is the issue. And this issue can be resolved by asking certain questions. I may be asking 3, 4, 5 different questions, and based on the response on these questions, I will be inferring about the level of motivation. I mean, there is no direct measure of it. So when we do not have direct measure of it in research, we preferably using certain scales, and in this case, we will be referring to the Likert scale. So for example, if I ask these four statements, how much I am sure that these four statements really measure the motivation? What is the reliability of these four or five statements that these will be measuring motivation, right? So, in case of regression, regression is applicable to the metric data or the data which is obtained on the ratio scale. But the moment we have the non-metric data like the Likert scale items or the interval scale items, this assumption actually become invalid. But still, if we want to use it, then we have to ensure that the values we are providing are valid and reliable. And then we will use these values for the regression purpose, but through the SEM. But to understand a little bit more, there are a lot of psychological constructs that we keep on measuring in consumer behavior, in employee behavioral aspect, and in psychology. So, for example, if somebody want to measure the social frustration, the frustration out of the social status or the social issues within a person, how one can measure it? There is no scale about it. And if somebody want to measure the stress level, again, only discussion is the way that we'll ask certain question and somebody will respond to those questions. Maybe by giving ratings, we can understand the person is under stress and what is the level of stress. Similarly, role efficacy, what is the clarity about the role, that also can be measured by using these kind of statements. So the very popular scale that we have, we use for the measurement of these kind of psychological construct is the Likert scale. Now, when we say Likert scale, this scale has certain items to it. Items is statement of the variables, and these statements are called Likert items. For example, I ask four statements. So each statement will be known as Likert item, and these four statements together constitute a Likert scale. That is important to understand. Now, there are two terms that we should understand. One is the concept, another is the construct. So what is concept? Concept is basically the general idea of any object or any item. So for example, if I ask what is motivation, you will have a certain mental images and you will explain what is motivation for you. You may be having some definition from a author, you can quote that as well. So we have very general understanding. We may have various kind of definitions. So those mental images, those abstractions are known as the concept. Construct is a kind of operationalized concept or a higher level of abstraction with more images, with more clarity. So we would say that construct is the measure which is created for the operationalizing concept. So we created concepts are the the created measure for the operationalized concept. So for example, if I want to measure role efficacy, so herein I will be defining what are the different things that constitute this role efficacy. I will be referring to certain things that actually indicate toward this role efficacy. What is the level of role clarity? What is the level of role and goal conflict within the person? Right? What is the level of expectation from the role? So these all are the different kind of measures that I have created to measure role efficacy. It means that role efficacy cannot be directly measured. We do not have any scale. But with the help of these statements, I can have fair idea about the level of role efficacy one could have. The problem is this concept must be have certain true value that we don't know. And we are here try to have the observed value that we observe. So because there could be certain variables that I can skip because of the context I'm conducting it, or because of my understanding of the concept, I may not be including all possible variables. So there would be definitely a difference between the value which is true value and this measure observed value, and this difference is called the measurement error. So here we have measurement error. Measurement error is due to the limitation of researcher uh, because of his understanding about the topic. So now connect. Yesterday we understood the concept of factor analysis. The factor analysis basically help you to give the structure of the construct. For example, if I may have these three different factors f1, f2, f3. So by using factor analysis on certain statements like 15, 16 statement I could have, and these statements will be reassigned to these factors. Out of these 15 statement, maybe 3 statement can or 4 statement can be assigned to factor 1, then certain statement could be assigned to a factor 2, and rest could be a factor 3. So what I have created here is nothing but a construct. This is a construct. The factor analysis help me to get the construct. Now if we use the equation, I can say that my observed values, that is for example x, is equal to the true value plus the chances of measurement error, because still there could be chances of certain more variable that could be allocated to these factors. I may have skipped in this list because these are not present in this list, they are not reflecting over here. So an error can occur because of that limited number of variables I use for the data collection. Now this T is the true construct that we don't know, but with the help of this observed construct, we try to have idea about this true construct. So for the clarity purpose, observed construct are measured on scales like 1 to 5 or 1 to 7, right? Not less than 1 to 5. And these scales are associated with certain statements, right? Now, if you remember, the regression equation is like y equals to beta naught plus beta 1 x plus ey. Now this y is my dependent variable, right? This x is my independent variable, and this is my error of regression. Now why I'm pointing out this here, because many times we confuse this measurement error with the term error in the regression. These two are completely different aspects, right? The value of this IV, that the value of x, it is obtained through this survey, right? And the value of y is also obtained through the survey, right? So we have these two values which are measured through the survey. We ask questions, respondent answer them, and we have the values, right? Because the data used here are non-metric, so so there are chances that, as I told Ki, there are chances that few variables may be missing out. But in case of regression, there is no doubt about the construct. There is no requirement of construct. In any of your regression study, you would not ever define concept using the construct. Why so? Because regression is applicable to the clearly defined concepts. And it is therefore, in case of regression, there is no requirement to figure out what is the level of measurement error. Yes, of course, there could be the errors due to the regression distribution that is there, but there is no as such measurement error. What we do here in case of SEM, structural equation modeling, as I told you, structural equation modeling is a kind of regression equation testing after including the measurement errors. What we do here is we actually utilize the regression equation, right? Or you may say uh, structural equation modeling is the testing of regression equation after adjusting the measurement error. So because measurement error does not measurement error was not included in the regression equation, so we require this SCM. Now in now SEM, we have two types of models. The first model is the measurement model, and second model is structural model. Structural model and measurement model. The structural model is obtained by the results of factor analysis, and this measurement model include the uses of regression equation. So you will be talking about covariance, or you will have separate measurement like correlation, right? All these values are there. You will have R square values in the results of SCM. So these are there. So in a sense, SCM is a combination of the factor analysis and regression. Why regression alone cannot be used? Because regression does not address the issue of measurement error. Why so? Because regression is applicable to the well-defined concept, whereas in case of structural equation modeling, we deal with the highly psychologically driven constructs. Now, in the while drawing the structural model, there are some standard notations. So we use a circle for the latent or the construct latent variable or factor or component. If you see the result of factor analysis, you will find this word component, which is popularly used as factor, and as per the concept it is called construct, and because they are not directly observed, so they are called latent variable. So for any of these we use this circle. Then we use this rectangle. This rectangle is for observed variable, right? For the clarity, these are the item statements. And these are also called reflective indicators. Right. And then there is an error term which is denoted by this. This is the error term. Right. Now there are two more terms that we have in AMOS. One is called endogenous variable, another is called exogenous variable. Now this endogenous variable is your dependent variable, like in case of sales and advertising. So sales is my dependent variable. It will be endogenous. So endo means incoming. So when you plot a model, all arrow from the dependent will be coming to the dependent variable, right? Exogenous, they represent independent variable, right? So for example, let us consider one factor F1, which has got a certain number of variables like V1, and V4. As I told, you will have the error values with them. So this is error 1, 2, error 4, right? So this is the measurement model. So the point is, because these are the reflective, these are the independent variable, and this is representing your dependent variable. So because these reflective or independent variables are pointing toward this dependent variable, it means the source to all these is same. So when we say that these four are actually defining this F1, isn't it required that we should check if we change any of these variable, how that will impact this dependent variable? Assessment of whether the score of these indicators co-vary with the scores in this vector. If, for example, I change this V1 and there is nothing change in F1, it means that there is no connect. It means that either the relationship is very, very weak, which is not demonstrated in the values. So why we are having this V1 then? We should drop it. Or if we say that it is important part of this factor 1, then if I change the value of V1, it should reflect the change in the F1 as well. So ultimately, we need to check the reliability, right? And here we need the requirement to check reliability of the factor that we developed after factor analysis, right? So issue of reliability arise here just because we are not sure or we want to be sure, right? So this is one measurement model. Before moving to this reliability part, let me also tell you one more aspect, which is you may have the different variables like x1, x2, x3, right? And they are also pointing towards the latent variable. Right? And they may be varying. So this is the latent construct. And these are the antecedent. Antecedent means I can change these values and I can see their changes in the scores of latent. So this is different from this one, if you can see here. Here we have the error values associated with every independent variable here, but these are not here. So basically, when we obtain the result of factor analysis, we have two options. One, the first one, that we want to confirm the structure that we have obtained through the factor analysis is fair or not. And second, the factor itself, because these factors may be related to some construct, like for example service quality, so the empathy level of the employees and the communication, and all these are the factors that actually affect the quality. So here what we are doing is that these are themselves are the factors, and this is the latent factor, which through these three we can define it. This is called the path model. We simply are defining the path here, right? Or sometime it is also called formative model. So the purpose of the both model different. Though when you use AMOS, you can be aiming to draw this one, or you can be aiming to draw this one, depending on your requirement. You may choose which is appropriate for your case. So now with this understanding, let us move to this part which is about the reliability of the factor. So what are the different measures of reliability? In case of SEM, it is essentially required to check two things. Number one, measurement of reliability and validity. So yesterday we talked about the Cronbach alpha for the structure, whether the structure is appropriate or not. You calculate Cronbach alpha. Cronbach alpha measures the internal consistency, and any value above 0.6 supposed to be good indicator of reliability. But when we talk about validity, validity has two aspects. One is the construct validity, and second is discriminant validity. Now this construct validity determined by using two measures. One is the composite reliability, popularly known as CR, and second is average variance extracted, AVE. So by knowing these two things, composite reliability and average variance extracted, we can conclude about construct validity. I tell you how this is done. And then we also calculate the discriminant validity, which actually is a kind of test that shows that if you identified three variables, F1, F2, and F3, are these really three different variables? How can I be so sure? This discriminant validity answer this question. And this construct validity, as the name is suggesting, is a kind of another test that ensure the composition of construct is good or not. So the question is how we calculate these. Just for the sake of checking, am I connected with all?
Yes, sir, you are connected.
Thank you, Sushant sir.
Can hear
Thank
you.
you so much. Thank you, sir. So now we see how we calculate these measures of validity. The first one is composite. I'm just taking an example, a very small example to make it a little clear. So let us first see what is composite reliability. So for example, if I have this V1, V2, and V3 kind of and then you may have the error terms associated with them, and then you connect these to a factor particularly, right? So when you conduct the factor analysis, you obtain the factor loadings, right? So this variable has certain factor loading for this factor. For example, let's take this is 0.6, 0.7 and 0.8. These are the factor loadings. And these help me to understand how these are connected with each other or not. So composite reliability actually measure the inter-item consistency after including or after adjusting the measurement error. So how it is different from the Cronbach alpha? Because Cronbach alpha also confirm the consistency in these variables with this factor. So if we have already calculated factor Cronbach alpha, then why there is a need of this composite reliability? Because in Cronbach alpha, do not adjust the values for the measurement error. And as I was telling you from the beginning, that this measurement error is very important term. Because if the measurement error is there and if it is detected in this place, I can change the structure of the factor by either dropping or by adding new variables, by collecting more data, increasing the sample size. The Cronbach alpha has a limitation of not including the measurement errors in its calculation, but in case of composite reliability, we address the measurement error. So how do we do this? The formula for this composite reliability, for example, factor number 1, is that summation of all the variables here from 1 to k lambda I. This lambda is nothing but your factor loading. It's a standard symbol used everywhere. Factor loading is represented by lambda. And divided by the summation of factor loading square plus summation 1 minus lambda I square, right? So this this lambda is nothing but your standardized factor loading that you have in your rotated component matrix or component matrix. The values that appear in the rotated component matrix in the factor analysis, those values are there. So for this case, for example, my composite reliability for factor number 1 would be like 0.6 plus 0.7 plus 0.8. I'll take the square of it divided by again 0.6 plus 0.7 plus 0.8 square, right? Now this is the interesting term. 1 minus 0.6 square plus 1 minus 0.7 square and plus 1 minus 0.8 square. Whole square nahi hai, right? Now this value that is represented here, this is the estimation of measurement error. Estimation of measurement error. We are, we are subtracting the factor loading from 1 every time. And this 1, I suppose the gold standard that okay, maximum true value could be 1. And what I have obtained is 0.6. So the difference of this is nothing but my estimation of the measurement error. So this value 1 minus lambda I square is actually related to the measurement error. So if I calculate this one and my value comes for factor 1 maybe greater than or equals to 0.7. This is the threshold limit. If this value arise, then I'll say, or it means that at least 70% of the items can be attributed to the factor. Means out of these 3, if I say for example 70%, almost 2 I'm confirmed, I'm sure that at least 2 out of 3 are related to factor F1. So any value greater than 0.7 is an indicator of composite reliability. Now you can see that factor loadings are not only utilized in case of the decision to construct factor, but they are also important in the calculation of composite reliability. And in a sense, because these all are converging. If you can see, the arrows are toward this one. So these all are converging to this factor. So we could also take this composite reliability as a measure of convergent validity. So if somebody asks to measure the convergent validity, you can refer to this composite reliability. I hope this is clear. Any question? Okay. The next validity measure is average variance extracted. AVE. And the formula for AVE is summation of lambda I square divided by K. What is K? K is the number of items in the latent factor. So for example, in this case, if I want to calculate it, the 0.6 square plus 0.7 square plus 0.8 square divided by 3. And the threshold value, we can calculate it now. The threshold value for AVE is 0.5. It should be less, it should be greater than or equals to 0.5. It means that on an average, the latent factor can explain 50% or more variance in the associated items, right? So remaining 50% can be attributed to this measurement error, because we could have the measurement error, and that because of that one, the value is this this much low. If value is increasing, for example, if I have 0.7 value, 0.8 value, it means the measurement error, the chances of measurement error are less. But 50% is okay, and any data set that has got the average variance extracted value 0.5 or greater, that can be considered, right? So if we have composite reliability greater than 0.7, average variance extracted greater than 0.5, we can definitely use now this result of factor analysis for the structural equation modeling. Before moving to the structural equation modeling, it is essential to confirm these two things. One more thing which is remaining here is the discriminant validity, and which is very important because you have to calculate it manually or by using Excel. Discriminant validity. So as I told you that discriminant validity help you to understand how far these factors or the latent variables are different from each other. If I have extracted 4 factors, so I must be knowing that these 4 are totally different from each other. There is no similarity, or there are no chances of similarity among these 4 factors. So how do we calculate this discriminant validity? So I am taking a case of 3 factors only. So I am drawing a matrix here, and this is how you have to also do by for your own results as well. So here is the factor 1, factor 2, factor 3, factor 1, factor 2, and factor 3. On the diagonal, we will mention the average variance extracted value for factor 1 to 1. Here we will mention average variance extracted for factor number 2, factor 2 and factor 2. Here we'll take average variance extracted for factor 3. How we calculate AV, that I have explained over here, right? Simple formula. Now on this lower side, we will mention the correlation coefficient of factor 1 and 2. If you can see, factor 1 and factor 2. So correlation coefficient of factor 1 and factor 2. Here correlation coefficient of factor 1 and 3. Here we have correlation coefficient of factor 2 and factor 3. On the upper side of this diagonal here, we'll mention the square of correlation between the factor. So R square of factor 1 and factor 2. Here we will take R square of factor 1 and factor 3. And here R square of factor 2 and factor 3. Right. Now, what we do here is we will look at whether my average variance extracted for factor 1 is greater than R square of F1 and F2 and R square of F1 and F3. So this value should be greater than the value of these two. Then we will not decide anything here. We'll check average variance extracted for factor 2. It should be greater than R square F1 F2 and R square F2 F3. Okay. And then similarly, average variance extracted to factor 3. It should be greater than R square F2 F3 and R square F3 F1 F3. Right.
Pankaj sir,
Yes.
sorry to interrupt you in between. Surbhi ma'am raised their hand. Hello, Surbhi ma'am, Surbhi Agrawal. Surbhi ma'am. I think by mistake she has done it.
Okay.
Sorry, sir. You can continue.
Right. So thank you, sir. But if somebody want to ask question, they can directly unmute and stop me in between. After this, we'll move to the AMOS interface. So the point is, now we compare these values, and after comparison, if we found that all these three values are greater than the values of their respective R square, right, square of the correlation, plus they also meet the criteria of this average variance extracted and composite reliability, then only we can proceed further for the model building. If there is an issue over here, for example, in case of 3 out of 3, only 2 have the values which are greater than their respective R square values, then it means there is something wrong in the selection of the variable in the factor structure, and the problem would be most probably, and in fact 99% would be about the factor loading. You may have considered factor loading which is very, very low. So while making the decision whether to include the variable in the factor or not, factor loading itself is a very important criteria. Yesterday we saw that while allocating values somewhere in the factor analysis process, we decide the value for 0.4. That 0.4 is the minimum value that we should look for. Any value less than 0.4 is of no meaning in any of the calculation, and therefore it is a kind of thumb of rule that we should at least involve only those variables which have factor loading greater than 0.4, right? So this is again the answer to the question that why we should focus on 0.4 value only. So yes, if this is the three factor solution to a problem, right? For example, I would like to understand the stress related factors. So I can say these are the three factors. But after understanding these discriminant validity, I figure out that this factor is weak vector and which is nowhere contributing to the stress. So I can drop it. I can go with the two-factor solution. So this helped me to understand whether I should go for the first order solution in the model or the second order solution of the model. Right? There are different levels to this one. One is the first order that we are focusing today, and then we can have the further extended one, that is second order solution to a model. These once we are confirmed with this one that factors are discriminated, they nowhere share any kind of similarity, we can proceed. And when we are also sure about that the composition uh, is fair good and it has been adjusted for the measurement error, then only we can proceed. Otherwise, if there are issues over here, your model will, finally when you see the results, there will be a lot of problem that you cannot even manage there. So to avoid problems in the later stage in the AMOS, it is essential to rectify some of the problems before moving to that AMOS solutions. Any question?
Achha, sir, I think that whatever you teach now, that all that related that work, I think we have to do it the manually and according as the manual to apply all the formula. I think there is no use of the AMOS here. Am I right?
Munawar sir, up to some extent you are right. Why I adopted this approach is that we are becoming more handy with the softwares. If you understand the use of Excel, you can simply make an Excel sheet and you can calculate it by using Excel. But if you have the result of the factor analysis, you possibly could have 15, 16 different variables with their factor loadings. So by manual calculation, you can still manage to have these values. So what my plan was that I was planning to share it by two methods. Number one, I can show you through the Excel sheet. Maybe that can not serve the purpose that how we can get it done by our own. So that is why I decided to go with this, literal writing the formula and telling that this is how we can do it. And it's very simple, nothing complex in this one.
I think we are following the method whatever you taught. Here we are going to jump from concept to the construct and the validity of the construct. Am I right?
Exactly, sir. Very true. If you see how the paper writing work, so normally you can have a problem which has the scope for the exploration of latent factor. So you either can use a standard scale, like in case of service quality we have cervical scale, service quality scale. In case of technology adoption model we have TAM model, that is again a scale. In case of tourism destination we have Riccian crowd model that have certain statements. So by using those scales, I can conduct the factor analysis. I will have the factors and the factor loadings. Then I can go with the analysis of the reliability and validity, and then based on those results, I may proceed for the structural equation modeling. So this is a sequence how you should proceed in the analysis which target the ultimate modeling of some concept. See, again, if there are already models that have been built or established, and you want your own model, and your factors are not validated, then there is no point of having a new model. So this kind of analysis will help us to defend the utility and the development of such model. Maybe sometime there are a lot of variables which are uncontextual for India, right?
Yes, suppose sir, we already applying for the some researcher applied the some model and we are manipulating those model, and in those model we are some adjusting the some our new idea, new our factor. So in that situation we have to go to through this calculation.
Yes, sir. See, even if you are using the same model exactly similarly, because data is obtained from the people where you are conducting your research. So there are two places where error can be occurred. One is the scale itself that may not have the variable which you should in your context is important. For example, in case of Delhi NCR, there are a lot of tourism destination. And the model I was talking about is Riccian Krauss model, which talk about the beaches. Beaches nowhere is a relevant variable in Delhi NCR.
Right.
So I need to drop it. But yes, in place of beaches, I should be including a replacement of it, which is more appropriate for this destination. So
Yeah,
similarly, in any case, you can have your own variables, and by using this approach, nobody can question if you are justifying, you are calculating, and you are meeting the threshold values.
Okay, sir. Thank you very much.
Please. So now we'll move to the next part of the session, which is about the interface. So I'm sharing my screen with you. Just a minute. This is it visible?
No, sir. It is
मैं
not.
पूरा screen share कर देता हूँ, एक minute. Are these visible, sir?
Yes, sir. Now it is
Yes,
visible.
sir, it's visible now.
Okay. So now this is the AMOS interface. I first of all explain the various, I would say, tools that we use for the building up a model, and then we create one model and test it with the data, right? So the very first thing is this white space. This white space seem to be very limited, but if you rotate the scroll your mouse a little more for forward and backward, you can change the size of it. So sometimes people feel some problem by looking at this space which is available here. You can increase the size up to any width and length, right? Number one. Number two, if you look at this side, left hand side, you have various options available here. So this is the white space which is called canvas, and here this is the rectangle box which is used to draw the observed variable. So if you hover your mouse over it, you can see draw observed variable. The circle is for the unobserved variable, and if you can see this uh, symbol or the icon, it is used to draw the latent variable with the indicator, right? So let us first draw one or two, because other become active only if I draw something here. So for example, if I draw this one and one more, right? Now if you can see, these arrows are active. So I may connect one observed variable with another one.
Sir,
I
sorry,
can
can
use
you,
the covariance.
sir, sorry, can you repeat again? Because I cannot understand due to some
Okay, just
connection problem.
no issues, sir. Just
Okay.
just give me 1 minute. We'll draw the observed variable by using this rectangle. You can again have the another rectangle box here, right? Now we can connect these two by using this arrow. So you may say that these are connected this way, or you may think these are correlated with each other. So either I can have this one, or right. So while drawing it, try to be little conscious that do not drop in between. For example, if I'm drawing here, it become red. Is it visible?
Yes, sir, visible.
Yes, sir. It is visible.
And if I draw the arrow to this one, it become green. If it is somewhere here, I can drop, so I will lose the arrow. So I should ensure that it is green, and then it automatically take its shape, right? And maybe I am looking forward for a variable which has got some of the error terms like this one. I need another error term. So likewise, I'm drawing right now. If I have to draw all these multiple time, it is a time consuming process. So how can I do it bit more easiness? I can draw it by using this one, right? So this is my unobserved variable. The circle is my unobserved variable. The rectangles are my observed variable, each with the uh, error measurement error value or error variance, right? So either I can draw one by one, placing using by these all circle and rectangles, or I can use this single latent variable with the indicator of latent variable. Next is this is about the title. If I want to give a title, so I can write, for example, figure 1. So this will appear here, right? This is figure 1. These two are the representative of how many variables we have in the model. Like in this case, we have 2 variables. So these if I click over here, I have not named it, because I have not named it. It is not reflecting here. But if I have these 2 variables, these variables will be shown over here. And this AMOS will work on a data set. So how many variables are there in my data set will be reflected by this other option of the ladder, which is here, list of the variable in the data set. So for example,
उन्हें पता होना चाहिए जैसे अभिषेक के केस में
sir, yes, please.
Yes, sir. Please continue, sir.
Okay. So I just show you how these variable will appear. Just give me 1 minute. What I'm saying. So let us add the data. So if you can see this square with lot of lines, it should select the data file. I click over here. I can go to this this file I have created for today's session. So I select it and open. This is the normal SPSS data file with an extension of .sev. And okay. Now if I click over here, I can see the variables here. Just to show you the file. Now, if you can see this SPSS data file, this is the variable view. Try to understand that this name has certain limitations. Like it has to be start with a string or alphabet. It would not start with the number. You cannot have the space in between. But in case of label, you have freedom to write even a sentence. But when we draw the model like this, right? If I am intended to draw a model over here, I cannot use statements. I cannot use lengthy words. What is essentially required here is to convert your variables into the variable code. So what you can do is, like I have done in this Excel sheet, is that I have give this V1, V2, V3. Are these visible? V1, V2, V3, all these are the variables and these are the statements. So I have replaced these statements by
visible.
I have replaced these statement by using these variable codes, and I have utilized these variable code in my SPSS data file here. You can see that variable name and variable label both are same, and for the reference purpose, I will be using this Excel file. Okay. So now coming to here. So these are the variable list, right? And then let us draw. If you can see this this printer like object, this is about for the duplication. So if I click over here and then select it and drag it, right? So I can create similar size box by using this one, any number, right? This bus, which is a kind of icon, is to move the object. So if I click over it, I can move these boxes to any places. If I do not require any of the object, I can simply click over this cross and then further click on this, the item that I don't want. Sometimes you may have the I would say you would like to change the shape of the box. Maybe you want to expand it, or maybe you want to reduce it. For this purpose, you have this box, or you can reshape it, right? Depending on a requirement, you can adjust it. So this icon is to change the shape. And rotate the indicator. For example, if I place right this, and I want to rotate it, I want this to be little down. So I'll do it. I'll select it, and now I go to this rotate. Click over here. One moment. So now if you have this complete set and you want to rotate it, then you can rotate it by using this rotated, this icon that representing this rotation button. Similarly, if you can see, there are certain values 0 and 1. You want to take this value to little lower side, or you want to take this one value to the left hand side. For this purpose, you have this circle, move parameter value. You click over here, and then you take this value to the any place, like for example this to this place. So these are basically the tools that you can use while drawing this model. And when we do the things and we become, or we face some problem, then we can explore these tools. And the more we use them, the more we can become handy about these tools. Like for example, this tool is to copy your model. So if you have draw a very beautiful model, you want to copy it to paste it on your Word document or a PPT. So what you simply do is you simply press over here, and the entire model, whatever be here, will be copied to the clipboard, and then you can simply paste it on your on a PPT or on a doc. This is to specifically increase a particular point. For example, this seems to be little small in shape, and I want to read the value. So I can first click on this lens and go to the place where I want to. So you can see the values are increased. Now how to reduce it? So for this, you have this another lens with negative, which means the more you click, it will be now furthermore in your same place. If you do not want any specific area of your diagram to be highlighted, then you can use this one to increase the overall size of the model. So these all are the various tools that you can utilize. Sometimes your model may become so clumsy and so complex that it may be touching the various part of this canvas, and you want that it should be automatically contract, and it should be in a proper form. So you simply click over this, right? To resize, it will resize the total entire path diagram, and it will fit that. If the size is smaller, it can make them bigger. If the size is bigger, it can make them smaller. So if you click on this, so it will reshape the entire model, right? So all these are the various tools which are available. I hope that these tools are clear to you. There is one more aspect that I want to share with you. Just give me 1 second. Yes. So if you can see, this is the path diagram I have drawn, right, roughly. Now I want that this entire diagram to drag to the upper side. So what we have discussed is this bus that can move the object. Now if I click on this icon and then take this bus to this part, and with right click and drag it, a part of this model is moving only. What my intention was to take the entire model to the upper side. For this purpose, what you will do is you first of all intact this symmetry and preserve this symmetry, and you want that anything here should not be changed when I drag it. You click over here first, number one. Now you click on this bus and then take it to the any place, right? If you want that this place to be changed, again uncheck this preserve symmetry, click over the bus, and now you can change it. So depend, see, more you use it, more you will be knowing about these various icons and their utility. Now I just want to share one example that is the purpose of this entire session, and we'll see how to interpret the results and how this entire thing will work. So let me take to this one. Any questions so far? Okay. So let us see. I draw one diagram here, right? Simple. Another variable here. And now what I am telling you for next 2-3 minutes, please note it down if you are writing it somewhere, because the values that appear here are little complex in terms of their representation. If you know, then okay, it will be kind of revision. But for those who are for the first time using it, try to understand. I am not making any complex model here, right? But gradually, if time permit, I will take you to the complex one as well. So I have drawn these two boxes, right? Now I have already added my data file by clicking over here, right? Select the data file. I click over this box, and wherever I place my data file, I click over the view data. It will take me to this is your data is already there, so it's okay. And then I click over this list of variable. So here is my list of variable. What I do here is I'll take this variable PU and then attitude. So the data set is about the adoption of a technological product, and we were trying to analyze the adoption of the technological product among the consumers. So one such factor was PU. PU stands for perceived utility, perceived usefulness. If the perceived usefulness is higher, then it is believed that attitude toward that product would be higher. So this was the scenario, this was the background of this data. Now I have created this one, close it, right? Now we go to this analysis properties, right? So this pop-up will appear. By default, estimation will be there, and by default it has two values: maximum likelihood and estimate means and intercept. Maybe sometime because of some manual problem or manual data error, there could be certain missing values in your data set, and you are afraid that those will intervene in your analysis part. So to avoid that conflict due to the missing values, you can select this estimate mean and intercept. If you are so sure that there is no missing value, you can uncheck it, right? Then come the output. I take only two here: minimization history and standardized estimates. Simply close it and save it. And this is the calculate estimate button. I will click over here. So if this output path diagram become red, it means your calculation has been done. Now, if it is not red, then there are some problem in your data set, and AMOS will tell you. It will tell you that maybe sometime you draw a diagram where you miss to name a particular variable. It usually happen with the error measurement or error variable. Sometime you may not connect the arrow properly. That is a missing link. Sometimes missing values could be there, and in the estimation you have not checked that value particularly. So it will tell you where is the problem and then get it correct and again run it. So if I click over this red button and go to standardized estimate, so what we here have is the value 0.42. This 0.42 is the correlation between these two variables. And there is a correlation of 0.42 between PU factor and attitude factor. Now, if I go to the unstandardized estimates, few more values are appearing here, and the value over the curve has changed. Like in case of standardized estimate, you can see 0.42. So please write down somewhere. If we are looking forward to the standardized estimate, and this is a two-sided arrow between two variable, then this value under the standardized estimate, remember it, under the standardized estimate, the value appearing on the arrow represent the correlation. And if I go to the unstandardized, now this value on the arrow is covariance, right? So now you understand where to find the covariance and where to find the correlation. Second, the values on the edges of these boxes, what these are representing. The first value, that is 2.31, is representing the mean of this. You remember you have taken the values from different participant of your survey, and then there are various components, or there are various variables in that particular factor. Like there could be, if I can show you here, these are the variable 1, 2, 3, 4, 5, 6. Out of these 15 variable, there could be 2-3 variables which may be constituting this PU factor, right? By using these variables, we have created these factors. So what we have done is, what this is reflecting here is the mean value of those component of this factor. 0.47 is the variance of the variable. So this 0.47 is the variance of this variable, right? And this 0.19 is the covariance of between these two variables. So now we have understood that where to find the correlation and where to find the covariance. Is this clear? Any doubt?
No, sir, no doubts. Absolutely clear.
Thank you. I think somebody else. Okay. Okay. So now, as I was telling you, this AMOS will pick up the values from this label, right? So whatever you mention in the name doesn't matter, but what you're writing in the label matters a lot in the model building, because in the AMOS, while drawing the diagram and when you're placing the variable, it will pick up the label that you have mentioned over here, right? So make sure that you have very short and crispy explanation of the variable over here. Now, let us do one more calculation, right? So if I want to change in it, I have to go to the initial path diagram, right? So I will click over this one, and now values disappear, and I can do the changes. If I am still on this red button, I cannot do changes over here. Right? For example, I want to delete something, I cannot, because it become inactive. So to make any changes in this model, you have to go back to the previous one. Now I delete all these and we create new one. So we pick up this one, right? I want exactly same box below to it. What I should use out of these options? I can use this one, duplicate object. We click it over here and then drag. So we took 3, and we also took one more here. Now we named them. So how to name them? We have to allocate variables. So we'll click over the variable, the data set. We pick up the PU factor over here, and then there would be perceived ease of usefulness, and then perceived risk factor in the technology product, and they will affect the attitude. Close it. These are my factors. We'll draw the lines to connect these. So this PU factor affecting the attitude, this is also affecting this one, and this is also affecting this one, right? And we also believe that they have some correlation and covariance values. So we'll draw the two-sided arrow between these such that everything corrected. Got it? There is a touch-up variable tool here. If you can see this one, a hand is holding a pen. If you click over here and click this on this, now you can see that it is actually making some touch-up here, and this I need to extend a little more. I will go to this place, and this is how right. So I hope this is clear. Now again, for the sake of revision only, the variables which are listed here, PU, PUU, and PR, these are the exogenous variables. And if you remember, I told you that the arrows will be moving from exogenous to endogenous. So attitude is my endogenous variable here, right? Now, we have already selected the data, so there is no need to upload file again. And now in this one, what we'll do is we go to output, squared multiple correlation, and then residual moments, modification indices, all these I have selected. Save it and calculate it. Okay, now there is a problem here. So what is the problem? It is telling the following variable are endogenous but have no residual variable, right? If you can see, I have created attitude factor, but this attitude factor, because it is endogenous variable need to have a residual variable, error variable. So that is not there because of this one. It is showing error. So what I can do, I go to this and then click over here. Intentionally, I am doing one more error. I run it, right? Again, repeating, I am doing it intentionally, I am repeating it. I click here, again it's showing an error. What is error? One variable is unnamed. Now you can see which variable unnamed. So this error variable is unnamed. Okay, we'll give the name to it. Simply double click over it and give name. Error 1. Right? So now we save it and run it. So you can see now it become red. It means that analysis has been done. We click on it and there are a lot of values which have appeared in it, right? So now these values, what these values are, can somebody tell me?
So linking the factor PU factor,
Yes.
PU factor to attitude factor, 2.31 is the mean, 0.47 is the variance, and then 0.30 is the covariance.
Right, sir. Right, sir. So these two-headed arrows are representing covariance, right? And this single arrow, there are values on single arrow as well. You were right that these values on this upper right side representing mean and the variance. So 0.47 is the variance and 2.3 is the mean value. Similarly, here you can interpret it, and these are the covariance. Now, what this value on the arrow? The value on the arrow are known as standard path coefficient, right? These are basically the regression weight, or you may say they are the regression coefficient. As I told you in the beginning, that this structured equation modeling is nothing but the combination of two things. One is the factor analysis. So we obtain these factors from the factor analysis, and we are modeling it by using backend पर तो काम वो हमारा regression ही कर रहा है. So these are the standard regression coefficient or standard regression weight, right? On the arrow. Now, what is value on this error term? So this value 0.35 is the error variance, right? So this was not adjusted in the normal regression equation, right? This is here only that it is suggesting that there is a variance of 0.3 which is not included because of these factors, right? And this value on the attitude, because this is the endogenous factor. Exogenous पे क्या आता है? We know, right? We know that this value representing the variance. Is it also the variance जो attitude factor के ऊपर है? The value residing on the attitude factor is the value of R square, right? So you may note down somewhere, endogenous will have the value of R square. The value over the error term will be the error variance. Two-sided arrow represent the covariance. Single-sided arrow represent the path coefficient or path standard regression weight, right? Now, let us do one more thing. We'll try to see where are the outputs. You may see this box, view text. If you click this view text, you will have this AMOS output, right? Analysis summary is there. कब conduct किया है इसको सारा detail आएगा. And then variable summary, how many variables are there? right? In your model, observed endogenous variable ATT, attitude is my endogenous variable, exogenous variable PU, PAU, and PR, and there is only one error term which is E1. So this is the detail of my summary. Then estimate. You click the estimate. There are two values over here, scalars and matrix. You click on this plus button over the scalar, and you have the regression weight, right? Regression weight on the line. ATT and attitude to PU, it is 0.30. Actually, it was 2.97. It rounded off and it become 0.30 here. Similarly, 1.56, the value is here. What is the purpose of using these table? You can see the whether these are significant or not. So my p values here are representing that this relationship is significant, right? If you click here, you got to know the interpretation of it. The probability of getting critical ratio as large as 8.892 in the absolute value. In other words, the regression weight of PU in the prediction of attitude is significantly different from 0. It means that whatever value is appearing here, it is significant value. So all my relations with the attitude, these factors and the attitude are significant. Then we could see the covariance. These all are the covariance value, 0.17, 0.16. It actually has rounded off 0.178. It make it 1.18 actually. So every value you can have in the table form, because diagram you would copy and paste at one place. But while writing the interpretation of your analysis, you need tables. Those tables are available herein. Then you have matrices. Now, why these where these matrices are required, I just tell you. Come back to little later. We'll just take some time. I'll close it. What I am doing here is it's not moving. Symmetry maintain, move it. Okay. Deselect all, maintain, move it. Okay, let us do this one. It is not moving. We add one more variable here, right? एक वेरिएबल और ऐड कर लेते हैं इसमें. Right. And we also add error term to this one. We name this error term. This time it will be E2, for example. Right. And what this endogenous variable is, we click to this one. So there are there are models which explain that sometimes people could have positive attitude, but it will not convert to their positive behavioral intentions, right? So for example, they are convinced that utility is there, it making some easiness and convenience, risk is less, so overall attitude is positive toward the technological product. But still, if they are not purchasing it or not using it, it means that there is some issue with the behavioral intention. So what we have done is we included a variable called behavioral intention here. So let us drag this behavioral intention to this BI, right? And we connect it with the help of this arrow. We click here and then, right? So these are the what we do. If you can see, can we see some new relationships here? Can we see some new relationships? Here are two types of.
Now BI is the endogenous construct, sir.
Yes, one is the BI is the endogenous, and one more
And
thing is
attitude is the mediator.
yes, exactly. This is the right word. attitude become mediator, and here we need to understand the role of attitude as a mediating variable. So sometime to make your study more interesting, you can analyze the mediating effect as well by using AMOS. So how we do it is, I'll explain here. Now, there are few direct relationship. You can see here PU4 to attitude and PU to this one. And there are indirect relationship like PU through attitude affecting the BI. PR, any perceived risk affecting the attitude, affecting the BI through attitude. So these are the indirect relationships. And these which are ending over attitude, these are the direct relationship. Now, for making it more interesting, let us create one more here, right? And थोड़ा इसको move कर लेते हैं. So now we have added one more arrow which is showing a direct relationship. If the perceived usefulness is high, will it directly affect the behavioral intention without affecting the attitude? Therefore, we create a direct relationship by using this arrow between PU and BI. We simply, okay, we have to now tell AMOS to analyze it. We go to the analyze property and we check this direct, indirect, and total effect. It was not earlier required, so we didn't actually check it. We click over here and then close it, save it, compute it. So now you can see it become red. Estimation has been done. We click over here. So if you can see, the standard regression weight is just 0.01, right? And the R square value of BI is 0.02. Whereas if you can see the standard regression weight 0.98 between attitude and BI, it means that combinedly these PU, and PR, if they are framing an attitude, then there are good number of chances the person will have positive buying intention. If we are considering only one factor, which is PU, and try to evaluate its effect on the behavioral intention, it is very, very feeble, it is very weak. It is just 0.01. Now look at the text about it. So these are the different estimates. We go to the estimates, scalars that I already explained you. Now we go to the matrix. Under matrix, you can see total effect. So this is the total effect, how the perceived risk affecting the attitude and how the perceived usefulness affecting the attitude and behavioral intention. I just want to see the indirect effect. So for indirect effect, now I think both are visible. Attitude has no indirect effect with PR, right? Because it is directly related to the PR. Attitude और PR के बीच में कुछ और नहीं है, तो there is no indirect. So you can see attitude, PR, POU and PU, इसके बीच में कोई indirect effect नहीं है because these are directly connecting with the attitude factor. But BI has got indirect effect with everyone, because BI can be affected through the attitude by these factors. So PR affecting the BI, right? 0.146. We click over here, you can see what it means is that if PR goes by 1 standard deviation, BI goes up by 0.14. and अगर PR में 1 डिग्री का कोई चेंज है तो उसके अगेंस्ट 0.1 का फर्क पड़ेगा BI में. And if perceived risk, how much perceived risk is impacting behavioral intention, it is showing the intensity of it. Similarly, if you click over this, you can find OU, if it is increased by 1 standard deviation, BI goes up by 0.15, little better than the previous one, PR1. So if you want to write the interpretation, it will give you the idea how to write the interpretation. You just simply click the value and you will have it. Then we click over this model fit summary, right? Whether this model is workable or not, whether this model is acceptable or not. So we see these values, right? The first value we see under this model fit summary is this CMIN, this value, right? CMIN is basically a chi-square minimization value. If you remember the formula for chi-square, it actually means the discrepancy. It's a counting based method wherein we count the expected frequency and the observed frequency, and we subtract all these two. If your expected frequency are matching with the observed frequency, this chi value will be 0, right? But if there are differences, then this will be reflecting under this CMIN value. Now, CMIN value need to be as less as possible, but for the interpretation purpose, we use this CMIN by degree of freedom value, which should be closer to 1, right? It should not exceed. And if you click over here, the default model, the discrepancy divided by degree of freedom is this one. So you can see that you simply have divided CMIN 3.838 by 2. Second is, sometime you may have very high value of CMIN here and very high value of CMIN by degree of freedom. In that case, your model is not a good fit model in the absolute sense. So what is the way out then? We should discard the model, or are there some other way outs? So there are certain baseline comparisons. So if this CMIN value are not favoring your model, this may be because of the small sample size, because it's a base of it's depending on the counting. If you increase the sample size, the value may change. So you should not mind if the values are not favoring, these values are not favoring. You simply go to the baseline comparison. In baseline comparison, you see these values: NFI, RFI, IFI, and TLI. TLI stand for Tucker-Lewis coefficient value, and IFI stand for incremental fit index. So if all these values are greater than 0.9, this means that your model is close to fit model or a good model, but not absolutely fit model. For absolutely fit model, you need to have this value under control. Then you have Ramsar value. Ramsar value actually help you to figure out how close fit your model in relation to the degree of freedom. If you read somewhere this rule of thumb, Ramsar of about 0.05, and any value which is 0.05 or less model in relation to the degree of freedom, it reflects a good fit. And if you have the Ramsar value, root mean square value, which is either 0.0 or close to 0, it indicates that a reasonable error or approximation would not want to employ a model with a Ramsar grade. Okay, 0.0 or close to 0.0 value reflect the good fitness, or if any value which is moving beyond this or toward the one side or greater than 0.1, then there is some problems in it. So these are some of the model fit measures. You can use these values to write the interpretation. So in the last, what I have planned is to discuss how to create a research paper by using this all what we have discussed in last 3-4 days. To conclude it, I just want to show you
maybe some idea, sir, if we can take the secondary data and we can make a model, some idea you can discuss about for to make the paper.
I'm so sorry, sir, but for the purpose of model building, you need primary data.
Uh-huh.
That data can be of limited variables or limited number of people. Yesterday, Mr. Tyagi told you that, for example, if your scale is constituted by using 10 different statements, then rule of thumb is you should have at least uh, some says 10 times of the variable. It means if you are dealing with the 10 variables, you should be having data of 100 people.
Okay.
10 times of the number of variables. It's a rule of thumb. Everywhere it works,
Ji, ji.
right? So if I want to conduct a simple research in my classroom, and my classroom has got only 50 students,
Okay.
so I should use 7 to 8 statements, not more than that, because then there will be the issue in the validity part. Or if I can club some more student into my sample size up to the 100, for example, then many times 10 statement are better.
Right.
So I show you the, yeah, please. Okay. Just give me 1 minute. Okay, so I am sharing my screen with you. Is it visible?
Yes, sir, it's visible.
So in 2020, what we have done is when lockdown was imposed and lot of restrictions were there, so we try to figure out restraining effect of digital payments and tourism prohibition to protect against COVID-19 transmission. Whether prohibition on the tourism, people cannot move from one place to another place, stressing on using the digital payment, will this work in stopping the transmission of COVID-19? That was the purpose of this paper, and we use this CFA approach, that is the confirmatory factor analysis approach. My co-authors were Dr. Ritesh Singhal and our director, Dr. T.R. Pandey. So I'm not going through this literature and this introduction aspect. I just come to the analysis part. So what we have done is we created this path model, theoretical framework, wherein we found that these 5 different variables constituting this factor: digital payment perception, reduce the people to people connect, fear of viral disease, less use of cash transaction, feel safe, secure. Based on the nature of these variables, we gave a name to this factor. SPSS does not give name to the factor by itself. You will use your understanding about the commonality among these variables and decide a name. So we decide the name digital payment perception. I mean, how people perceiving about digital payment, and then conviction in the tourism provision. How much people are convinced that tourism provision will stop the spread of COVID-19. So these are certain more 5 variables. So we obtained these after the factor analysis. Right. So this is the Cronbach alpha 0.8. It's a good value. Then the KMO test and Bartlett test is tell us that whether your sample size is adequate for the factor analysis or not. Any value more than 0.59 or 0.6 is in acceptable range. So my value is 0.8. It says that the sample size we consider is is good enough for this analysis. These were the two variables. If you can see here, TP1, TP2, TP stand for this tourism, this perception toward the provision to the tourism, and then next one was digital 1, digital 2, right? This is about the perception about the digital payment. And these were the factor loadings that are considered here. We calculated percentage of variance explained, eigenvalue alpha, and mean value. This is the model we created, right? So structural model, standardized estimates of interaction F1 and F2. So now you understand that what this value is representing is the covariance. These values are representing the standard path coefficient values, and these values are representing the variance values. So everything is now, I think, clear to you. And then these are the with modification. Yes, one more thing which I forgot to discuss is that just give me. Let me share one more time. Okay. We go to this analyze properties, and if you can see modification indexes, I checked here, right? Modification indexes. What is this modification index? Sometimes your model is not fitting, not in absolute term, not in the relative terms. So AMOS will tell you that if you do this thing, your model can be more appropriate. So modification indexes should always be in your results. So we have checked it. So I hope it should be there in our. Yes, here is a modification indexes. You click here. So there are no modification indexes, right? There is no suggestion from the AMOS to this model. This is the one and only model in this case. So sometime you will have these values here. MI stand for modification index, and peer change stand for percentage change. So it will suggest you if you want to change the variance. Sometime you need to correct the variance. Sometime you need to correct the regression weight. Sometime you need to correct the means. So for different purposes, it will give different suggestions to you. So, for example, if you are, if it is given that by combining the errors terms of these two, right? There will be an improvement in the overall variance. So you will create an arrow from this to this, and then run the model again, and you will see the values in your result output. Those will be improved by the values it suggested here in the percentage change. So modification indexes are very important that we referred in our case as well in this here, right? Structural with modification, right? If you can see here, so we have added the error variance of 9th and 7th. But while doing it, please remember this: you cannot combine or club the variance of this factor with this factor, and you cannot draw a two-sided arrow from E6 to E4. This will be error. Sometimes it is suggested in the modification index, and therefore it is a debate. If AMOS is suggesting to do this one, why we cannot do this one? Because what we are doing is as per the guideline of AMOS. But the point is, as an investigator, you should remember that if you are sharing the variance of F2 with the F1, then why there is a need of having these two factors? Combine it then, have one factor only. So if we are claiming that my model has two factor, we should not combine the variance, right? And then this is the entire model that we developed. These are the variables that we disclose, and the discussion, and finally this paper was published. So this is what I was planned to discuss with you all. I hope that I may have justice. If you have any question, please ask.
Sir, there are research papers wherein the researchers have used confirmatory factor analysis. I mean, first exploratory factor analysis and then confirmatory factor analysis. And there are researchers on the contrary who are also using, I mean, after applying exploratory factor analysis, they are using second order confirmatory factor analysis. So can you please throw some light on that? I mean, why are some using exploratory and confirmatory, and then why there are other set of researchers who are using EFA and then SCFA?
See, I told you that there are two models. One is measurement model, right? And another model, which is the structural model. So in case of structural model, when you test the reliability and the composite reliability and the discriminant validity, you may realize that there is an issue with one of the factor. Now, the point is, or the, I would say, speciality of AMOS is you are not allowed to drop any variable at this point. Whatever variable you want to combine, drop, you can do it in the factor analysis. Once you have explored your factor and confirm their validity and reliability, and now you are planning your model. If there is no issue in your validity part, discriminant is meeting the threshold values, composite reliability is meeting the threshold values, Cronbach alpha is good one, then, and the model fit summaries are supporting your model. There is no requirement for the second order. But the problem where second order are required is when your existing structure of model is not supported by the results. Then you need to change the, I would say, assignment of the variables within. You can drag it to the next level. So for that part, we said the second level of the analysis. If there is no issue with your liability and all those parts, then there is no requirement for the extended one or the second level. This is point number one. Point number two is when one should use structural equation modeling and one should use the confirmatory analysis. In a way, when you are dealing with the measurement or the path analysis only, when you're concerned with the path analysis only, you just want to confirm the structure that you have explored in your factor analysis are okay with this data or not, are fitting with this data or not. Right? You are not bothering about the other next part, which is the regression weight and other things. You just want to confirm your path model, path diagram. Then you are dealing with only two aspects, exploratory factor analysis and confirmatory. But when you are concerned with the measurement model as well, path model plus measurement model, then here is the role of structural equation modeling. Right? So these are the steps. One more thing. The most common practice is that the data we use for the exploration of factor, we use the same data for the confirmation. As per the standard material available and the authors, it is not recommended. Why so? Because if you have developed a model by X data and you are using the same data to get it confirmed, it is obvious that your result will be confirming. Point is, once you explore your variables, recollect data and run that model on that data set. If you have the same results, then only your path diagram and those structure will be confirmed. So these are the explanation for your point.
Sir, I have one more question. Sir, please, can you please throw some light on the differences between reflective indicators and formative indicators?
Yes. So path diagram are the reflective one. See, where you are not concerned about what is causing what. My intention is just to check whether the structure I have obtained, right, through the exploratory data analysis is my reflective one. And the second one, wherein I'm much more concerned about what is causing which one, and wherein I'm concerned about the cause and effect relationship. I am more interested in figuring out how much my independent variable is affecting my dependent variable. Then this is so this is what my point is.
Thank you, sir. Thank you.
Dr. Ritesh?
Yes, sir.
From my side, it's okay. If anybody has got any question, then we will discuss.
Okay. Participants, if you have any question, so forum is open. We can have a discussion on it. Is there any question from participants?
Sir, I have a question. Sir, generally we are all the faculty. We would not have a time to make the empirical data and to collect all the data. We are looking for to publish some empirical research utilizing all the secondary data. What is the convenient the software which can to help us to make some analysis work, and maybe our paper will be available to publish any good journal, not in any good journal, maybe it should be published in any average journal. So what is the, if you have some idea, you are doing the PhD and you are the scholar, so maybe you can please tell me.
Munawar sir, it's a $1 billion question, because every scholar would like to invest less time and to have the work, because you are right that we all are faculty member, full time we are doing our job, and there are a lot of other works because of those reasons we don't have enough time. Software can only help you to conduct the analysis. As long as the structure and the idea of the research is concerned, it's your part. If you do not have much time, then you can reduce the size of your research. You can reduce the periphery of your research. But as such, there is no software which will itself write the entire paper. One thing what you can do is use the Grammarly. Have your own, I would say, the literature review through the Grammarly. So when you write your references, it will help you there. You can use some other tool, like on the second day, our speaker was telling how to calculate the sample size. There are a lot of online calculators that will help you out. So in bits and pieces, you have various tools, but as such, there is no one single tool that will help you to actually convert your idea into the research paper. You can collect some of the tools for your own purpose and then use them. My advice is what I do usually, that what I'm referring to you is, it's not advice, but what I'm referring is my own experience, what I do. I do very basic research. Like, for example, you can conduct cluster analysis by using the data you obtain from your students. Now, clustering, the moment we heard this term clustering, then all sort of algorithm will immediately jump to our mind. But if you understand the use of scatter plot and Tableau, then you may develop your own methodologically driven approach that is equally good as the normal clustering algorithms are. So sometimes we have to mine the techniques themselves to find their unobvious uses. As I am telling, that scatter plot is a diagram which we normally refer when we are establishing a relationship between two variables. Can't we do more with this scatter plot diagram? If you explore this, you will figure out there are a lot of things you can do with this simple two variable data set. So it's a matter of exploration, but as per my knowledge, there is no single software or technological tool except this ChatGPT. ChatGPT now people are using to generate content. Sometimes it also help you to generate the questions. If time permit, can I share, sir? Ritesh, sir?
Sir, I think the same thing is being shared in the tomorrow session.
Okay. No issues.
Thank you very much. Thank you very much, sir, for insightful your observation and the guidance. Thank you.
So thank for your praising, sir. Thank you so much.
So I think there is no more question from participant side. Feedback link is already being shared in the chat box. You can do it. So Pankaj sir, we are going to close the session today. Ladies and gentlemen, On behalf of AKGIM, I would like to extend our deepest gratitude and appreciation to Mr. Pankaj Chauhan for gracing us with his invaluable presence and sharing his expertise during this faculty development program. Mr. Chauhan, your session was nothing short of exceptional. Your profound insight, engaging delivery, and passion for research left an indelible mark on all of us. Your ability to connect with our participants and inspire them to strive for excellence was truly remarkable. Throughout your session, you effortlessly conveyed your wealth of knowledge on effective research strategies and creating a nurturing learning environment. Your expertise has equipped our participants with a renewed sense of purpose and the tools they need to foster a culture of research within their institution. Once again, we express our deepest appreciation to you, sir, for sharing your time, expertise, and passion with us. Thank you for being an invaluable part of our program, and we wish your continued success in all your endeavor. Thank you, sir.
Thank you, Ritesh sir. But I am a part of AKGM family. I think that you spoke much, much, much. But anyway, thank you so much. All these are the motivation. And thank you all the participants for listening me or sometime bearing me as well. I didn't prepare my slides because I think that writing on the board is more connecting tool. So for any boring session or boring part of the session, I extend my apologies. Thank you so much.
Thank you, sir. And dear participants, tomorrow's session would be on research ethics and plagiarism detection and removal techniques. You please be there, and hopefully and most probably we'll be sharing certificates with you on tomorrow itself. Most probably we'll try for this, and do not forget to share your feedback come attendance link. Thank you. After submission your feedback, you may leave the session.